All right, so this lesson we're going to be talking about expanding logarithms. So one of the cool properties of logarithms is that you can either condense them all into one, or you can expand each logarithm into multiple logarithms. And this, again, could help us find redundancies. It can also help us eliminate logarithms because there's a couple of properties I hopefully will get to show you here as we go over these. So looking at number one, so you'll see it's log 6 times 11. Okay, like we talked about in other videos, if it's not there, there's an implied base 10. But again, because it's implied, just like how there's an invisible 1 in front of x if it's not there, you don't have to write base 10. We assume it's there, but I'm just writing it there just to help remind us that it's base 10. And I'll do that just for this first problem. All right, so in a logarithm, so you notice how it's 6 times 11. Okay, whenever you have two numbers inside of a logarithm that are being multiplied, you can actually split these into two separate logarithms. So you could write log base 6 of 10, log base 10 of 6 plus log base 10 of 11. So I can expand this one logarithm into two separate logarithms. The way that you'll normally see it is like this. So if I have a log base 6 of 66, okay, what you can do is you can expand that logarithm into, what's a different way I can make 66? Well, you might say, 2 times 33. That's correct. So you could write log base 6 of 33 plus log base 6 of 2, because 2 times 33 is 66. But some of you might have said, well, wait, Mr. Schwandt, you could have wrote this another way. You could have said so 66 is 11 times 6, which is true. So you could have broken this up by log base 6 of 6 plus log base 6 of 11. So either way is fine. You could expand it any way. So like on number one here, it was already broken apart for you. They told you it was 6 times 11. So we just wrote log base 10 of 6 plus log base 10 of 11. So whenever it's multiplication, you can split it apart into two separate logarithms and add those two logarithms together. Okay? And again, if it's just a single number and it tells you to expand, you can expand it to whatever you want, and we'll go over particular ways that you would do this later. All right, so for number two, again, very similar to number one, I can make this log 5 plus log 3. And just in case you're wondering, wait, where did the base go? I thought you said there would be base 10. Remember, there is, but it's implied, meaning I don't have to write it. We assume that it's base 10 if there's no base written. So we can just write log 5 plus log 3. All right, number 3, this brings up another issue here, actually a couple. The first thing we want to deal with is this exponent. Whenever I have an exponent inside of logarithms, we can actually do this with them. They could move to the front of the logarithm. So this 5 is going to move in front. So it's going to be 5 log 6 divided by 11. Okay? So if I'm expanding a logarithm, we can move exponents to the front of the logarithm. And again, if we were condensing, which we'll go over a little bit later, you can actually move this back up top to be an exponent. But because we're expanding, we're going to move that exponent to the front. And then let's talk about number one. So in number one, it was 6 times 11. We split it into two different logarithms, and we added them. What do you think we do when we divide? Correct, we subtract the two logarithms. So this time it's going to be 5 log 6 minus 5 log 11. And the reason why I subtracted is because it's 6 divided by 11. Remember, if it's a fraction, it's actually a division problem. And so because I'm dividing, I subtract the two logarithms. And notice how the 5 I moved to the very beginning, is in front of both. Because look at the beginning. See how this exponent would apply to both the 6 and the 11? That's why we write the 5 in front of both logarithms. All right, number 4. All right, notice how the exponent only applies to the 2. Right? If it was this instead, let's say the 3 wasn't there and it was on the outside, yes, we could move it in front. But because it's only affecting the 2, we first need to expand and split them apart, and then we move it. So this is what we do. We're going to split this up. This is going to be log 3 plus log 2 to the third power. Then we're going to move that third power in front. But see how it only affects that second logarithm. Log 3 is still log 3, but then it's plus 3 log 2. All right, so that's how we deal with a situation like that. Essentially the same thing here on number 5, but when I divide, I subtract the 2 logarithms I'm going to make. So it's going to be log 2 to the 4th minus log 5. And then I have the additional step of moving that 4th power. So it's 4 log 2 minus log 5. And then here at number 6, the exponents affecting both of them, so I'm going to move that into the front. So I have 6 log 6 over 5. And with division, we subtract the 2, but the 6 will go in front of both logarithms. So 6 log 5. All right, so those are some examples of how we expand logarithms, and these are actually the easy ones. The next video I'm going to do will actually go over and talk about how we do the more complicated ones.